In this video, we will be discussing the Let's Learn the Basics section on page 168 of the SHIN-CHU-MON Mathematics for 9th grade. This is the second in a series of videos about the Pythagorean theorem, which is also sometimes called Pythagoras' theorem, after the Greek mathematician Pythagoras, who is believed to have first proved it. As you may remember, the Pythagorean theorem states that when the lengths of two sides adjacent to the right angle in a right triangle are A and B, and the length of the hypotenuse is C, the relationship between the lengths of the three sides is a squared plus b squared equals c squared. Now we're going to prove that this theorem is true. Let's begin by reading the question. There are four congruent right triangles in square ABCD below. The lengths of the two sides adjacent to the right angle in each triangle are A and B, and the length of each respective hypotenuse is C. Using this figure, prove that the Pythagorean theorem is true. Now let's take a closer look at the figure. This question tells us that each of these four triangles are congruent. That means that the lengths of their sides are equal and the measurements of their angles are equal. It also mentions that these triangles are right triangles, and each of their right angles are noted with the right angle symbol. Notice also that the sides adjacent to the right angles are labeled A and B, and the side opposite the right angles are labeled C. C is the hypotenuse for each of the right triangles. Now we will prove that the area shown in green, when added to the area shown in orange, equals the total area of square ABCD. First of all, we see that the area labeled 1 and shown in green is the area of the four right triangles. Since the area of one of these triangles equals 1/2 AB, the area of four of the triangles equals 1/2 AB times 4, which equals 2AB. Next we see that the area in orange, labeled 2, is the area of square EFGH. Since each side of this square is of length A minus B, the area of square EFGH is A minus B quantity squared. This then simplifies to A squared minus 2AB plus B squared. Now substituting in these values for 1 and 2 below, we get 2AB plus the quantity A squared minus 2AB plus B squared. And since the area of square ABCD is C squared, we can write that here. Simplifying, we get A squared plus B squared equals C squared. And since this matches the expression for the Pythagorean theorem, we have proven the theorem. Hopefully this video has been useful. please check out the other videos available on the SHIN-CHU-MON channel on YouTube. See you next time.